Bolts and other threaded fastening devices are so basic to industry that industry simply couldn't exist without them. This nut is an example of internal threading. Internal threads make ideal fasteners, so it's important to be able to create them quickly. The tap is the basic tool for cutting internal threads in a hole. And the actual process of cutting threads is called tapping. In this case, it's called hand tapping. To use a tap well, you should know a little about its construction. The sharp cutting teeth are located on the body of the tap. A series of grooves called flutes run along the entire length of the tap. These flutes help create the cutting edges of the teeth. Flutes also serve as channels for the cutting oil, and they store the waste material during cutting. The most common hand taps that you'll find in a machine shop have 2, 3, or 4 flutes. The construction of a 4-fluted tap allows more waste storage. It also allows more teeth to bear on a cutting surface, and that makes a more accurate thread. The name hand tap is just a tradition. It also applies to a 2-fluted tap used in machine tapping. The flutes are not used for waste storage, so they're made shallower. A 3-fluted tap is another hand tap used in machine tapping. It will make a more accurate thread than a 2-fluted tap. To understand the construction of a screw thread, you have to know a few technical terms. For example, the distance from one tooth to the next is called pitch. The crest is on the top of the thread. On a tap, the crest shows the most wear because it does most of the cutting. The part of the tap not cut away by the flutes is called the land. The threads of the tap are found on the land. The leading side of the land is called the cutting face, and this face is responsible for the proper cutting action of the tap. The chamfer is the angular slope at the front end of the tap. This taper allows the tap to gradually cut deeper and deeper threads until they are completely formed. At the opposite end of the tap is the shank. The end of the shank is square, so it will fit some sort of wrench. There are several available. One is the T-handle tap wrench. It's adjustable and comes in a variety of sizes. Another widely used wrench is the straight handle tap wrench. This one is also adjustable, and so is the offset tap wrench. The longer handles of offset wrenches and straight handle tap wrenches have greater leverage and are more apt to break small taps. A screw thread is identified by combining the major diameter with the number of threads per inch. If you examine the shank of the tap, it will give all the details concerning its specifications. For example, this tap indicates a major diameter of 1/2 inch. And the 20 here tells you that it has 20 threads per inch. Properly identified, this tap is called a 1/2-20. If a tap is not properly identified, you can find the number of threads per inch with a 6-inch rule and simply counting the number in 1 inch. Or a screw pitch gauge will also work. The gauge has a series of notched blades which are accurate for both depth of thread as well as pitch. To use a screw pitch gauge, simply try any number of blades against the threads until you find a perfect fit. American Standard and Unified Standard taps that are between fractions of an inch are given gauge sizes, numbered from 0 to 14. The shank has other information on it, too. The NF on this tap tells you the thread series it belongs to, the American National Fine Thread Series. NC tells you that this one belongs to the American National Coarse Thread Series. Taps are made of carefully hardened carbon steel or high-speed steel. The HS marked on this tap indicates that it is made from high-speed steel. Most standard tap threads are ground for greater accuracy and identified with the letter G. The accuracy of the thread limit is also marked on the shank. For example, this H5 marking corresponds to the H5 in this table of values. It indicates that the tap is slightly bigger than the standard, and the threaded hole it makes will have a looser fit. A general method for measuring whether a tapped hole is loose or tight is by means of a thread limit plug gauge. The limits of the fit are machined into the ends of the gauge. The go thread being tested here should fit the hole, but the no-go thread at the other end will be too big. If a tap has the additional lettering LH, it has left-hand threads and cuts in a counterclockwise direction. Now let's take a look at the kinds of hand taps and how to use them. The most common hand taps come with straight flutes and are made in three basic styles: a taper tap, a plug tap, and a bottoming tap. A taper tap has its front end tapered at least 6 to 9 threads before its full diameter is reached. A taper tap is used for threading holes that go all the way through the workpiece. A plug tap can produce threads close to the bottom of a blind hole. It can also be used with open holes, so it's considered a general purpose tap. A bottoming tap has only a 1 to 1.5 thread taper at the end of it, so it cuts right up to the shoulder of a blind hole. A bottoming tap is used only after using a plug tap first. The design of a hand tap demands special attention when using it. Knowing how it cuts threads will help you understand why it's used the way it is. When the tap is advanced, a series of chips are formed. It's the formation of these chips that causes tap pressure, resistance to cutting. The chips break off when you back off on the tap, so the tap can be turned forward again to cut new chips and create threads. If you don't back off on the tap frequently, the tap pressure can actually cause the tap to snap off. Let's get on with the actual tapping by placing a drilled workpiece in a bench vise. Lubrication ensures longer tap life and allows smoother and more accurate threading. To start tapping, cup the tap wrench in the palm of your hand and insert the tap into the hole as straight as possible. Start the tapping by applying steady downward pressure and make about 2 clockwise turns for right-hand threads. Once your tap is started, back it off to relieve tap pressure and chip buildup. There is no set rule for how far to turn the tap before you back it off, but never force the tap once it begins to bind in the work. If the tap feels like it's binding, stop. The binding you feel is a chip forming in the thread you're cutting. Back off the tap and break the chip being formed. Shorten your movements when reversing the tap until you can feel it turn freely in the thread you have cut. When you have 3 full turns completed, use a square to check for squareness. Remove the tap wrench from the tap first. If the tap has not been started squarely, restart the tap by favoring the direction required. After making a full turn this way, check it again. Lubricate the tap occasionally while working. By working the tap back and forth, you clear the chips away and allow oil to penetrate and make cutting easier. Your threading is complete once you have gone beyond the front taper and have used the full diameter of the tap. Wipe away the chips and excess oil with a shop rag, and then check the threads with the correct size screw. The screw thread, without it, We couldn't join metal parts that can be disassembled easily. And there would be no threads possible without the use of hand taps.